Okay, we are looking at section 6.7, problem number 65. I've made an example here that's similar to problem 65, and we'll work it all the way through. So here are our integrals that go with inverse hyperbolic functions. And the first thing we want to do is look at our integral and see which pattern it matches. So I look at this and I see a square root and I see a plus sign. So that tells me that this one belongs with inverse sinh. Okay, so I want to make this look like square root 1 plus x squared. So right now it's a 4. I want it to be a 1. Let's go ahead and take our 2 on the outside here. So 2 on the outside, integral from 1 to 4, and then we'll have 1 over. And to make this a 1, I got to factor out of 4. So let's go ahead and factor out of 4. And I'm going to switch places on these because t squared plus 4 is the same as 4 plus t squared. So if I factor a 4 out of here, I've got a 1 left. Factor a 4 out of here, and I've got t squared over 4. And you can check here that if you multiply the 4 back in, you get 4 plus t squared. Okay, so now I can break a square root apart here. If it's a product or quotient, you can break it apart. So this will be 2 times the integral from 1 to 4. I get 1 on top, and on the bottom we've got square root of 4, and then square root of 1 plus t squared over 4. So now this t squared over 4, we want our integral to look like this. 1 plus square root 1 plus something squared, quantity squared. So the t is squared, but the 4 is not. So I want to ask, what do you square to get t squared over 4? So this will be 2 integral from 1 to 4. 1 here. Square root of 4 right there is 2. And then in here, I've got square root 1 plus, and I want a single quantity squared, dt. So the square root of t squared over 4 is t over 2. So t over 2 quantity squared is making it look like this. So now I got to do u substitution because I'd like to have a u in here. It'll be 1 plus u squared, and then it looks just like our pattern. So let's let then u equal t over 2, or 1/2 t. And so your du is just going to be 1/2 dt. So 1/2 dt, so notice that that's right here. There's our du, and this is our u. So we've got a 2 out in front, integral, and then this will be the 1/2 dt, that's your du up on top, and then in the denominator we've got square root 1 plus u squared. So now it does look exactly like this. We do have to change our 1 and 4 over to u values because those are t values. So plug them in here for t. So 1/2 times 1 is 1/2. And then plug the 4 in for t. 1/2 times 4 is 2. So now the integral is all changed over. So we got a 2 out in front. The antiderivative of 1 over root 1 plus u squared du, that's this antiderivative, is going to be inverse sinh, but it's u instead of x. So this is 2 inverse sinh of u, and that gets evaluated from 1/2 to 2. So plug in the 2, plug in the 1/2, and subtract. So this is going to be 2 out in front, inverse sinh of 2 minus inverse sinh of 1/2. And we got it. That is a numerical answer. Now this might not match what's in the back of the book. They've written things in terms of logarithms, which is that identity that you can use to swap out for inverse sinh. You do not have to do that for me on this problem. Okay, so you should be able to do something very similar to this, except you're matching a different pattern because you've got a minus here instead of a plus. Hope that helps.